Now we can take some questions. I have a few questions that were emailed in to Rosa in advance of the session. One of the questions was, what are the best filtration options to make the sanitation system more effective? I think I addressed that. What I would add to that is you have to obviously ask what type of sanitation is going to be used, and also what are your discharge restrictions and the water chemistry. We've found that really for a sanitation system to be effective and to not spend additional money unnecessarily for the system or additional money for the chemicals that go into the system, that filtering down to at least 25 microns or better is, while not absolutely necessary, very beneficial for any type of a system. In some types of systems, like UV, for example, you really want to make sure you're down to the 5 microns or less before it goes into a UV system. Another question was, what are some of the preventative measures to take to avoid clogging of irrigation lines? I think I addressed that. Know your water chemistry. What's in the water? Is it undissolved organics, dissolved organics? What is it that's clogging the irrigation lines? If you're not sure, cut it open and take a look. And if you can't tell what it is, send it into a lab and have it looked at. Send it in to us. We'll look at it, or bring it to our lab. Take a look at what percentage of clogging. Maybe it's just a bad emitter. Maybe it's not a problem. So what percentage of all of your emitters are really clogged? I think that's important to know. Is injecting copper effective in keeping mist lines clean? That's really not part of the subject, but typically you would need to have a faster acting oxidizer to really get to really effectively keep mist lines clear. And keeping mist lines clear, let's be clear about it. What we're really talking about there is biofilm and killing biofilm. And so you need to ask the question, what is it that will kill a biofilm? And that's the oxidizer that you need to choose to get that done, to keep them clean. I've got a question here about having a little bit of trouble, but should I be using a material, but what material should I be using? I'm using a 220 micron filter now. I think one of the things that I showed here, and I'm not sure if you meant mesh or micron, 220 micron really is not very good filtration. That's fairly coarse filtration. And if you're really at 220 micron or 220 mesh, you need to increase your filtration substantially. That won't eliminate all problems, but it'll reduce them even further. There's also a question in here, a couple of questions about filtration of algae. And Paul, you might want to chip in on this one, but I think that at 10 microns or better, we start taking out most algae particles of that. The real question I have in there is, if you're using filtration to filter out algae or any other pathogen for that matter, you need to be very careful about what you're accumulating on your property. Where is that going after you filter it out? If it's a backwashing filter, where is that going? Is it going into a pond and you're reusing that, or is it going into the property where it may in fact pose a threat to the plants in your greenhouse? Are you building your own bacteria farm on your own property? It's probably not a good idea to do that. So anytime we're dealing with an algae or a bacteria or some type of a pathogenic material, I think it's really important. If we need to get rid of it, then get rid of it. Filter it out and oxidize it, kill it, and get rid of it. Filtration really reduces the demand for a treatment system, but it isn't a treatment system in and of itself. It just reduces the demand for a treatment system. Why is membrane filtration not advised to be used for treatment? For the same reason that I just mentioned with algae and removing pathogenic materials. There's two sides to membrane filtration. The downstream side is the discharge. If you're removing that and back flushing that material, where is it going? It's going on your property, and you're going to need to deal with that. The other is if you're removing pathogens with, and you're using an RO system, for example, or membrane filtration as a primary method of disinfestation. You're not really disinfecting, you're just taking the infestation out of the water. That will blind a membrane very, very quickly. And blinded membranes wear out faster. And so cleaning membranes is extremely expensive. Replacing membranes is even more expensive. So utilizing membrane filtration for pathogen removal is just a very expensive way to do it. It costs a lot of money to buy it, it costs a lot of money to operate it, and it costs a huge amount of money to maintain it. Much better to utilize fine filtration, like some of the filters that we just went through, get it down to the below 15 microns or so, the smaller the better, and then add a disinfection system to that, whether that's chlorine dioxide or ozone or UV. There are pros and cons of each one of those, but a disinfection system is what really should be used for disinfection, not a membrane system. That's just too expensive to use.